Now that our new milling cam project is created, the next thing we need to do is define the cam part. The cam part definition informs SolidCAM of the following. The post processor we'll be using to output G-code for our CNC machine, the coordinate system or origin for all our machining operations, and finally the stock and target models. These definitions are made using SolidCAM's milling part data dialog box, which is displayed in the SolidWorks Property Manager here on the left. Let's take a look. This milling part data dialog box is where you can specify all the information that is relevant to the current CAM project. The information can be edited at any time. As we move down the list, our first step is to select a CNC machine controller to handle our G-code output. If you click the drop-down, a list of post processors currently installed on your system is displayed. For this example, let's choose the G-milling post for a 3-axis Haas. Below the selection, the program number defines the block number of the first line in the generated G-code. The subroutine number defines the number of the first subroutine procedure in the generated G-code. For this example, let's leave the default values as they are. Next, we'll create our coordinate system, also known by many people as their home position. The coordinate system defines the origin for all machining operations of the CAM part. It corresponds with our built-in controller functions. To start the coordinate system definition, click the Define button to display the CoordSys dialog box. Now, we are presented with several options to define our coordinate system. We can define the coordinate system origin position and axes orientation by selecting model faces, vertices, edges, or even SolidWorks coordinate systems. Choose the first option, which is also our most commonly used option, called Select Face. By choosing Select Face, the moment we click on a specific face in the SolidWorks graphics area, the coordinate system will be created with the z-axis perpendicular to that face. For this CAM project, go ahead and select Top Center of Model Box from the Place CoordSys Origin to drop-down list. Again, pick on any top-facing surface of our target model. Our coordinate system will be automatically created at the very top center of that surface, as we can see here. The coordinate system axes are represented graphically by color. The x-axis is represented by the red line, the y-axis by the green line, and the z-axis by the blue line. After we finish this process, click OK at the top left of the CoordSys dialog box. The CoordSys data window will appear where we can control our default machining levels. Now let's quickly run through what these represent. The tool start level is the Z level where the tool comes to directly after a tool change and where the tool length compensation is activated. The clearance level is the Z level where the tool will retract to when moving from one area of the part to the next. The part upper level defines the height of the upper surface to be milled, and the part lower level defines the lower surface to be milled. For this example, let's click OK to accept the default Z levels. You have just created your first coordinate system, Mach 1, Position 1. Click OK to accept. Our next step is defining our stock and target models. In the Stock and Target Model section, click the Stock button. Now, it is recommended to model the stock ahead of time in SolidWorks, but it's not required. SolidCAM can define the stock model using several different methods, without a 3D model actually being present. For this example, let's use the default option of Box to define the stock model. Click anywhere on the target model in the SolidWorks graphics area. You'll see a bounding box automatically appears. With the Expand Box At section, we have control over how much material is added to the target model in 6 directions. You can simply enter the appropriate values based on your workpiece dimensions. So, for example, in our X plus and X minus directions, as well as our Y plus and Y minus directions, set the values to 2 millimeters past the part. In our Z plus direction, we'll add only 0.5 millimeters of stock material to the top of the part. Lastly, let's add 5 millimeters in the Z minus direction so we have material to clamp onto when we are machining this part. As we alter the values of the input field text boxes, Notice the stock material is updated graphically in real time. Once we have the dimensions set, click the Add Box to CAD Model button so that this geometry, which represents our stock, is displayed at all times. Click OK to accept the stock model definition. Next, we should move on to defining the target model. As I pointed out earlier, the target model is the final shape of the workpiece after the machining. SolidCAM uses it for things like rest material calculation and gouge checking in the Solid Verify simulation. To start the target model definition, click the Target button. Then, simply pick on the target model in the SolidWorks graphics area. The target model is highlighted, and you'll see that Solid 1 appears in the Type section. Click OK to accept the selection and move back to the Milling Part Data dialog box. In the next section, called Part Settings, you can define a number of parameters that are specific only to the current CAM project. These settings can also be accessed through the SolidCAM Manager, which you'll see shortly once we confirm the CAM part definition. And in the Machine Options section, you can input unique information that is related to the selected CNC machine controller. We don't need to use this option right now, but it's worth mentioning for future possible use. Lastly, in the iMachining Data section, you can define the machine and work material parameters used for the iMachining technology. For this series of Jumpstart videos, however, we will not be using iMachining. Finally, we can click OK. When the Milling Part Data dialog box is confirmed, the SolidCAM part file is generated and stored in the specified user directory. In the SolidCAM Manager on the left, all the information of the current CAM part is displayed. Using the right-click menus, you can manage things like the CAM part definition and the part tool table. And now that it's fully defined, you can also add the operations to machine this CAM part, which we'll do in the upcoming videos. And that concludes Part 2 of the SolidCAM Jumpstart lesson, where we've defined the CAM part. Join me for Part 3, where we'll add the machining operations. I'll also talk about the operation interface and how the workflow in SolidCAM is set up to easily define our operations.